in this case, we're going to the well type module, where you will be able to use this tool that has this well radius locator. In this well radius locator, you will be able to see all the wells that you have. In this case, I'm going just to, for this academic purpose, I'm going to check on this, the both field. I'm going to select all formations. I mean, I know that for both, the hook information is the most important. And if I want to select, for example, let's check the unfortunate of this field. I'm going to open in another window. Just give me 1 second, in a couple of minutes. Another field. You will be able to select a well and check on these the radius that you want in order to select. For example, let's see, 2 meters away from the F11 well, you have the F12 and this well, which you can't visualize. Let me see if I can. No, unfortunately, give me just 1 second and let me open the demo server, which I've been using it to show this. Give me just 1 second. There you go. Excellent. The landing page, the well type module. There you go. And this is a well type. Let's remember that why we want to know the nearby wells of a well. Well, if we want to create a forecast of how a new well it's going to be, it's going to produce, we need to find like nearby wells or common wells to compare and to create a well type curve in order to assign that new well that well type, right? Let's go then again into our well radius locator. I have here two fields. Let's select Alana A. We have, for example, here we have several formations. Let's just select all of them. And yeah, let's, for example, here we have 2 wells, only 2. Let's increase the radius. And as you can see, the selected well here, 195, it's close to the 196. And close to the 600 meters, you have these 2 wells as well. Let's select, for example, another well, the 208. And as you can see, if we decrease the radius of search, we can increase the selected wells, 500. There you go. And here we have the selected well that we wanted, and then I added the radius of my choosing, and so on. We have the nearby wells close to this well. Okay, so this is a very useful tool in the scenario that I a couple of minutes I just narrate you. But this is the tool that it's available in the well type module. As well, you have access. Let's go back into the agenda. You have it on the Alana web on the front end, but you have it as well on the AlanaPy script. Let's go into our Python screen, into a Jupyter Lab, and let's review the process on how to access this this functionality in a Python form. Okay, so let's remember that this is the basics Let's run this nearby was from the demo server. This is a markdown, but title. Let's remember that we need to import the fundamental libraries, pandas. In this case, I'm going to use getPass. I'm going to instantiate a couple of things here. Let's delete the field development plan and the well type. This is the module or this functionality. It's stored on the class data source EDA. So I'm going to instantiate only the data source because I'm going to need the well names and the well master. And I'm going to instantiate as well the data source EDA, which contains, then again, the class or the function nearby wells. Let's reset the kernel. Okay, let's run this. Let's run this. Let's remember that the AlanaPy script functions with yes. Let's import AlanaPy. I'm going to delete this Alana API version 2, and I'm just going to stay with the AlanaPy. There we go. Let's run it. Let's remember that this AlanaPy, it's already been installed with the PyPy source. In order to access this API, this functionality of AlanaPy, you need access to your token, to the token that it's given in the Alana web app. Let's just review it, how to get it. If you go into your account settings, here you have the Alana token screen. Once you provide your credentials and you click on login, you will it will pop out a little screen that has a very large string. You copy it and you paste it here in the getPass functionality of Python. As such, click enter. This variable will be, let's run it again because the kernel execution wasn't properly shown. Let's do it again. There you go. This is the fourth execution of the kernel. You have like this password icons. And here I'm going to, instead of using the open server, I'm going to change the domain to demo, to the demo domain. As simple as that. If you, for example, want to create, if you want to talk with us and create a server of your data, the thing that we are going to do is create another server, and this means that we're going to create another domain with your, or in this case, with the server in question, and as well, the password or the Alana token will change between servers due to privacy settings that we've applied into the Alana structure. So in this case, I'm going to declare the data source as the master class. I'm going to execute this, and if everything's going fine, we're going to get the classic connection established successfully. Okay, excellent. So everything's working so far, smoothly so far. So let's go and check on. We checked. I said that we're going to work with the Alana wells, right? So I'm going to paste. I'm going to use this get wells fields dict functionality of function of this instantiate class, the data source, and this will give me all the wells from these Alana fields. I'm going to store this in a variable, in a list variable that's going to be called list wells a equals. There you go. I'm going to store it here. What else? What else would I need? I would need to get the well master. Let's remember how to get the well master. Well, into the class my API. yes, the data source, we have a function. If we click on tab, we're going to be able to see all the functions stored in this class. And we're going to go here into the get well master. Let's remember that if I execute this function, it's going to bring me a list of dictionaries with its IDs, with its keys and items. Fortunately, pandas a function called data frame, which converts this structure into a data frame, as simple as that. I'm going to store this as the well master. There we go. What else? What do we need to do here? Well, as we're talking about the server, we're talking about formation FK and some things here. For example, field FK that has to be much more into the how a database is structured. So I will need to replace, in this case, the field FK, because I want to work only with the Alana A field. So I'm just going to copy these couple of lines of code that I previously done, which does exactly that. It's going to create a dictionary from fields, and it's going to change these fields and create a data frame only that has the field FK or the field as Alana A. And as you can see, we have these wells with its correspondence UTM in X and the UTM in Y. Let's remember that this geographic reference, it's the one that it's going to work with these nearby wells functionality. I'm going to use as well a very interesting source of visualizations, such as Plotly. I'm going to import Plotly with Python, and I'm going to create a function. I'm going to kind of vaguely explain you the function, which is a figure, Plotly figure that we're going to feed him, or we're going to input a data frame, and it's going to plot the X, the Y, and it's going to have a hover text with the well name, because we want to see that those names, right? So I'm going to run it. There you go. In order to execute this function, I would need to call it. So I'm going to feed df well master. And so on, we have these wells. If we hover here, we have the 211, 207, 201, and so on and so forth. Excellent. I tweak the function, this function a bit. I chose auto size false, a width, and a height to kind of visualize it in a much more easy way. I'm going to select, for example, I'm going to select the 215 well, the Alana 215 well, and I'm going to store it into a string. Then let's go, and I instantiate the EDA, right? The data source EDA. I don't remember how I call it, but it's ED, how I call it. I'm going to open it, and as you can see here, in right now, this class has only this run nearby wells function. If I see the doc string, we have the description that says get nearby wells given a well name and a radius around in meters. The arguments, it receives a dictionary with the key well name and the key radius. Let's copy the dictionary and we are going to, let's create another block here and we are going to declare. Just 1 second. Have it in a more slick way. Let's declare dict well type. Well, dict nearby of 1. It's going to be this dictionary. Let's place them in like the basic dictionary form in Python as such. And the well name, we're going to replace this empty string with a string well underscore 1. There you go. The radius, let's call it 500 meters. I'm going to put the radius. And I'm going to feed this dict nearby dictionary into well name is not defined. Yes, this is a string. And there you go. The keys are in strings, and I'm going to feed this into the dict nearby wells nearby underscore 1. Let's run it and let's see what happens. And as you can see, the server gives you back a list of wells that are close to the previously selected the selected well. If I vary the length in meters, I'm in this case only 2 wells close to the other, to the 215. In fact, it's only 1 well. The other one is the well in question. But fortunately, I created a function that plots these nearby wells, right? So I would need first to convert this response structure into a data frame that I could use to plot it. Fortunately, if I run a classic PD data frame and the response form that is stored on the key data, as you can see, this is a dictionary and this is the key. If I run this, I would be able to, yes, of course, nearby well. Let's replace it here. It's going to make the request again, and it's going to give us a data frame structure of the nearby wells that are close to the well that we wanted. Let's increase the, let's increase the space between them, between the nearby. There you go. And we have these wells. And this data frame, let's call it df nearby 1. To copy this variable, and I'm going to feed the function plotly_df with plotly, what happened? Plotly_df. We are going to feed this data frame and let's run it. And there you go. Close to the 215 well that I wanted, this one, we have these 4 nearby wells. Simple as that. This is the workflow in order to get the nearby wells of any given wellbore that we want to analyze, and in further cases we want to create a well type. Let's just I'm going to how much time we have. Okay, let's leave it like with this example. Let's remember that all of these workflows are going to be able in the documentation section of Alana.